So we are approaching here the entrance of the Vienna Microcity Lab in the University Biology building here in the second floor. And what you see here is the machine from the Viscom company made in Germany, and some other facilities, storage and photograph stands and computers for reconstruction. This is the machine. It's custom built according to our needs by the company Viscom in northern Germany in Hanover. It weighs about 5 tons and has 2 by 2 by 2 meters approximately in dimensions. It was quite a challenge to bring it here to the second floor in this other building, but it's up and running now. It's a self-shielding gear, so we don't have to worry about radiation. And I can just open up the door now. So you see the manipulator moving here. And now the door is opening. It's all pneumatically, very safe, with 2 circuits that prevent any radiation if the door is open. And that's actually the heart of it. That's the X-ray tube with the vacuum pump, and this is the generator. And that's the rotation table on the manipulator, where you can drive the object in front of the tube or more to the detector that you see here. Doesn't look fancy, this thing, but costs more than a German Supersportwagen. It's a flat panel detector, a digital one. So we don't have any conversion from analog to digital. It's a direct digital recording here. And here's some examples of what we do usually. Well, that's not the absolutely usual thing, but we can scan Stradivari violins. They are large, as you see, but this scanner is built to handle large objects. That's one of its big advantages, and we can do a spiral scan. Or here, something that was just published and in all the media, as you probably recognize, the famous Venus from Willendorf that we scanned here. But we also do other stuff like this here, which is just an artificial ceramic sponge. So we do some material probes also for other companies and colleagues, including also geological samples like drilling cores and stuff. Or for the medical people, this is a radius with an implant. But that's more the stuff that we are used to work with. That's, by the way, the famous skull from Israel, Kafzi 11, one of the first modern humans that was there by around 100,000 years. And we can handle whole skulls here in the scanner. This scanner, as you see, has a resolution of 70 micrometer. So we got just a probe in, and I'll just show you how this works. See the thing working, the red lights are on, and there's already a live picture from the inside. So that's an X-ray picture. We do usually 1440 around the object and then calculate the volume files or slices from them. We of course care for safety, so you see a Geiger counter here, and the machine is in operation now, but you see there's almost no radiation coming. I mean, that's the typical values that you get in microsievert that you get if you go out the building and wait for the tram. You would have about the same kind of radiation.